All right, same announcements today as last time. Just the reminder that homework 7 is due next Monday. And then you should be working on the project. I had somebody stop by after class last time and showed me basically they've completed all the heavy lifting for the project. They've got the spreadsheet set up. I mean, there were a few little tweaks they needed to make to finish the first 4 sections of the project, but it was effectively complete. So I was happy to see that, and I hope that everybody else is, at the very least, read the assignment. If you haven't even started the calculations, hopefully you've started thinking about it. Today we're going to do in the in-class exercise an illustration to help drive home the point of why you shouldn't just use IRR for comparing alternatives, why it can be used for initial screening, but it's not suitable for selecting the best alternative. And then we're also going to go through external rate of return analysis another time. Remember, I said that that's one of the handful of techniques that students seem to struggle with on the exams, and so I wanted to offer another opportunity for us to go through that together. Any questions on the announcements before we continue? Okay, so remember that a company's criteria when you've got mutually exclusive alternatives, talking about you're only going to pick one project to satisfy a certain need, is that you would want to select the alternative that yields the most profit to the company. And the counterintuitive thing is that sometimes the highest rate of return is not associated with the overall most profitable project. So sometimes those two things overlap. You know, sometimes it's true that the project that is the most profitable also has the highest internal rate of return, but there are situations when that isn't true. And I've constructed one of those just to make the point with the in-class exercise that we're going to start on. So what we're going to see as we work through this together is that you can't just compare projects by their internal rates of return and know which one is best unless they both have the same initial investment at time 0 at the beginning of the study period. Now, the illustration we're going to look at is 2 projects, one of which is like the cheap alternative and one is the more expensive alternative. So let me hand out this paper to you. And we're going to do the internal rate of return the old-fashioned way. Well, not super old-fashioned. We're not going to use pencil and paper. That would be the most old-fashioned way to do it. We're going to do it with Excel, but we're not going to use the IRR function. I mean, we can use it to double-check, but I'd like for us to get practice of setting it up to solve for the present worth. And remember, the definition of internal rate of return is that's the rate of return that causes a balance between the inflows and the outflows. Did everybody get a copy of the handout? Okay. So let's just start Excel. And we're going to need each one of these different alternatives to be referencing a different rate of return possibility, because we're going to be solving for each of them what is the internal rate of return that brings the inflow and the outflow into balance. So just to set this up, it's year, amount, PV of amount, and then we're going to do this first one for, I'm not loving this drawing tool here. Project A, and then project B will have amount and PV of amount. Okay, so we start at 0 and go through 10 years. Oh, no, it's still there. So we're not just going to have a single interest rate. We'll start with 1% for both of them, but we're going to try and find out like what interest rate brings the total down to 0 for project A and for project B. So refer to an individual interest rate for project A versus project B. So by definition, the internal rate of return is the interest rate, which makes the inflows and the outflows equal to each other. So the total should be 0 based on what the interest rate is. And so 1% is too low, 15% is too high. You know, now that this is negative, that tells me that it's too high. Just to refresh your memory of the concept, there was a figure that we looked at earlier which kind of made the point between the interest rates being too high and too low. It's this one, where if you're discounting the future revenues at too low of an interest rate, then your present worth will be positive. If you're discounting the future revenues at too high of an interest rate, then the present worth would be negative. So in our example, right now, 15% is too high of an interest rate, 5% is too low. So we can just do the goal seek, and the objective here is for the total to be 0 by changing the interest rate for project A. And it looks like it's 12.41% is the internal rate of return of project A. And now I need to do the same thing for the interest rate related to project B. Okay, so let's just kind of write a conclusion here. The IRR of project A is 12.41%, and the IRR of project B is 10.28%. Now, on part B of the handout, it says to calculate the present worth of each project using the MAR as the interest rate. So the MAR, which is given, is 4%. And for this illustration, we can think of that as how much we're paying to borrow money. Like if we were getting a loan in order to finance the initial purchase, then that might drive what we view as the minimum acceptable rate of return. So I've given you the factor is 8.1109. So using that as the factor, the question is, what's the present worth of each project if you're discounting the revenues to the present and combining it with the initial purchase price? So calculate the present worth of each. We can do that by hand, or you can continue with Excel. I've given you the space on the page there to do it by hand. I guess to do this with Excel, all we'd need to do is change the interest rate. I'm going to create a copy. So down here at the bottom, this was finding IRR. And then if you create a copy of it, and we'll call this next one finding PW at MAR, all we have to do is change the interest rate to 4% for both of them. Okay, so the conclusion is if the MAR is 4%, then the PW of A is 22,998.06 versus a PW for B of 28,552.54. So what should we do? That's what it asks in part C of this. Which project should be selected? So the one we should select is the one that yields the most profit. And even though option A has a higher rate of return, we can see from the present worth analysis that it's project B that yields the most profit. So you should select project B. It's the most profitable of the two options. And the way we can think of this is that if we're borrowing money at 4%, and so we have to pay back, some of our profits are going to cover the cost of borrowing. They're going to cover the interest that the lender is requiring. Because we need to buy equipment. Whether we're going with project A, we have to pay $50,000 for the upfront investment. Project B requires $85,000. But project B is entitling us to a greater amount of revenue each year. Like if we think about the difference between project A and project B, project B yields an extra $5,000 per year in profit compared to project A. So later on, we're going to do incremental analysis, which says, compare the difference between the two. Project B versus project A. So project B costs an extra $35,000 to initiate. And for that extra upfront cost, what you're entitled to is an extra $5,000 per year. And it turns out that that's worth doing, that it is worth spending $35,000 a year extra to get that extra $5,000 per year if your borrowing cost is 4%. So that's what the MAR suggests. And so the answer to that part D, the concept question here is, if you're borrowing money at the MAR, then the present worth represents your share of the profits. It represents, there's all this revenue coming in, and some of that goes to repay the original investment plus interest, and the present worth of the future profits when discounted at the MAR represents the leftover profits that you would keep after the loan is repaid. Okay, so hopefully you'll remember this on the exam, because inevitably sometimes students, when I'll say compare project A and project B, which one should be selected, they'll just calculate the internal rate of return of both of them and then pick the one that has the highest internal rate of return. And that is a mirage. Like, you can't use it for project selection. You can use it for initial screening, and both of these are acceptable projects. Both A and B will yield profit. We saw that both of them have a positive present worth when discounted at the MAR. So if we were using this for initial screening, we'd give a thumbs up to both project A and project B. Both of them are acceptable. But if they're mutually exclusive, that means we need to pick only one of them to satisfy the need. And it's project B, despite the fact that it has a lower rate of return. So this is saying it's better to earn 10.3% on an investment of $85,000 than it is to earn 12.4% on an investment of $50,000. So project B is more profitable. The present worth analysis will always identify the most profitable project. So you can trust that. You can always trust the present worth analysis to pick the alternative that's the most profitable. So internal rate of return is good for initial screening. Anybody have questions about this first one that we've done? All right, so when we did the, yes?
Can you scroll down to the bottom and get to it?
Sure, yep. Let me zoom in on it as well. So the profits come in the future, discount them at the MAR, then that's basically accounting for your borrowing costs. And if the present worth is positive, that means the project is profitable. And how profitable, like how far above zero that is, represents the present value of the profits that you as the project owner would get to keep. Okay, so next, we're going to look at another external rate of return problem. And the warning I gave you is that, when you do the exam, you're not going to have a template file to start from. That you're going to need to start from scratch when you do external rate of return analysis. And so I'd like you to do that. Now, you can refer to the handout I gave you last time, or you can refer to, you can look at your in-class exercise from last time. We did one on Monday. But here we've got an initial investment of $15,000. You can see the series of payouts and a couple of outflows. So remember, one of the big warnings is that if there's both an inflow and an outflow in the same year, you should only apply the net of that. So you shouldn't put both in year 5. There shouldn't be an outflow and an inflow in year 5. You should take the difference between the two and only include one of them in your spreadsheet. All right, so I'm going to pause. I'm going to myself also start solving this together, and then once I've got it set up, I'll circulate around in case you're having any trouble and need help finding an error on your spreadsheet.